So where we left off yesterday was looking at inverse functions, and I told you that you can go to the textbook, and the textbook would have great pictures of what it looks like. One thing that we did not get a chance to do was we didn't get a chance to just talk about what these inverse functions are. So basically, when you're talking about inverse functions for trig functions, our inverse trig functions, here are, we wrote them out, the sine, the cosine, the tangent. So we have the sine inverse function, the cosine inverse function, and the tangent inverse function. So how do we use those? I think you've had an opportunity to use those before. So if I tell you that y, let's say x is equal to the sine inverse of 1. Well, because it's an inverse function, I can then take the sine of both sides. So let's make this the first example. So I can take the sine of x. On this side, I'll get the sine of the sine inverse of 1. Okay, so the sine of x says the sine of x now, but we know that the sine of the sine inverse, these are inverse functions, so they cancel. So we just end up getting the sine of x is equal to 1. So now what we're trying to find is the angle. So x is the angle whose sine is 1. X is the angle whose sine is 1. But we have a restriction. All right, so if you remember the domain of the sine inverse, let's call, let me not write it like that because that looks like a derivative and that's bad. So if f of x is the sine inverse of x, then the domain of that function is the set of all x such that x is between minus pi over 2 and pi over 2. So the value that I can choose for x has to be in that domain. So what x am I going to choose? There's only one x in that domain that has the sign equal to 1. You're welcome to unmute yourselves.
Is it 0?
Okay, so what we take, so what is the sign of 0? Who's talking? Destiny? I can't tell
No,
who's
it's
talking.
Lauren Smith.
Lauren? Okay,
Yeah.
so what is the sign of 0?
Mhm.
Do you remember? Let's
Huh.
go back and look at this picture. So here was our sine function. So the sign of 0 is right there. Okay. So the angle we want is not 0 only because the sign of 0 is 0. The angle where the sine is 1 is right here. It's this angle, which is pi over 2. Now, I'll tell you guys right now, I do not in any way, shape, or form remember um, the trig functions like this. I remember them. That's why I gave you guys a trig circle. If you look back on Blackboard, you will see there's a trig circle. Okay, so when I look at this, I know that I have a, but Lauren, thank you for answering. I'm going to help you see why your answer needs to be adjusted. Okay, so if you have a unit circle, I should have drawn the, I think I should have drawn the, oh no, yeah, well, that's pretty awful. I need to move my, if I have a unit circle, this is so frustrating, but I'll get it. There we go. Okay, so here's the unit circle. So the sign is the y value. So this is the point right here, 0, 1. So the sign is the x, the sign is the y value. So this angle is pi over 4. So that value we want is pi over 4. Okay. All right. So let's try.
Pi over 4.
It's pi over 2. I don't know why I said pi over 4. It's pi over 2. I don't know where the 4 came out of my mouth. It's pi over 2. This angle right here, that's pi over 2. Thank you for correcting me. Okay, so now I want to solve for x. Okay, so the cosine inverse of minus the root of 3 over 2. So now I'm going to use the cosine. So now I'm going to get the cosine of x. I'm taking the cosine of both sides. Is the cosine of the cosine inverse of negative root of 3 over 2. All right, so that says I want the angle where the cosine of x is equal to minus root of 3 over 2. So where is that angle? Well, if the
5 pi over 6.
5 pi over 6, that is correct. Was that Ian?
Yes, ma'am.
Thank you. Okay, so if I go back to my circle, I need the one value where the cosine is minus the root of 3 over 2. Well, the minus the root of 3 over 2 means I'm going to be in this quadrant because the cosine is the first value. The sine must be a half, so I'm somewhere around here. And so this angle right there is 5 pi over 6. Now, what was my restriction? Well, remember, our restriction for cosine was that if f of x is equal to the cosine of x, then the domain of that function is the set of all x such that x is between 0 and pi. All right, so the last thing I want to just say about this was the other ones. So, oh, this should be cosine inverse, not cosine. Cosine inverse. Did I make sure I said sine inverse back here? Yes. Okay, so we know that the sine inverse of x, f of x equals sine inverse of x. We know its domain, set of all x, such that it goes from minus pi over 2. We know cosine. So the cosine inverse, its domain, we already said, I just wrote it, was 0 to pi. then tangent its domain is also minus pi over 2. But the difference is you can't include it because at pi over 2, the tangent is infinity. So we don't have a value there. So the cotan inverse. So it is between 0 and pi. Again, we can't include those. Lastly, the last two are cosecant inverse. And this one is also minus pi over 2. And x cannot be 0. And then the last one, that's not what I want to say. Cosecant, secant. So we can't, I think that's right. Yes, those are them. Okay, any questions? All right, let me give you one to work on. If this were a recitation, so you know what? Whatever. If this were a recitation, Mr. Williams would actually be doing problems with you. So what I'm going to do is just do a problem, okay? Find the inverse functions. And then find and inverse functions, their domain and the range. How about that? Okay. Anybody want to start talking me through the first one?
Well, we replace f of x with y.
Okay, that's right. So in the first one, we start off with y is equal to x cubed minus 2. Good. All right, and then we replace it.
We switch to x and y.
Okay, what do we do next?
We plus 2 to both sides.
Okay. And then next.
And then we square cube both sides.
Okay. All right, so we have our, so now, and then the last thing, what do we do? What's the last thing we do? We call this our inverse function. Okay, so that's our inverse function. So what's the domain of that function? What kind of numbers x can go into that function?
Anything less than 2?
Anything less than 2?
Anything
Okay.
more than 2 or 2.
Anything higher than -2?
Anything higher than -2? Wow, I'm getting some good answers here. Anything else? Let's say I put in 0. Does that work?
Yeah.
Okay, let's say I put in -5. Does that work?
Yes.
Yes, because I can take the cube root of a negative number, right? Suppose I put in 8. Does that work?
Yes.
Yeah.
I can, so one of the things you can do, we didn't do this because we can't always graph the thing. But for this one, if we were to just go back and graph it, our original function is y is equal to x cubed. So if I were to graph that, that would look like this. So here's y is equal to x cubed. But our function says subtract 2 from that. So the function we have looks like this. Now, we already know that the inverse is always going to be flipped over. The axis y is equal to x. Every inverse that we did, look, was flipped over an axis. Here's the flipped over. Look at it flipped over. So I can do the same thing to this one down here. And I can flip it over. This is harder to draw than one would think. There we go. So that's what that's going to look like. But even if I didn't graph it, because it's a cube root, I can take the cube root of anything. So therefore, what's the domain for this function? I could write x is a real number. In other words, x is an element of the real numbers. I could write the domain of f is the interval minus infinity to infinity. I can write the domain of f is the set of all x such that minus infinity is less than x is less than positive infinity. And I am pretty sure that this is what your homework is going to be looking for. What's its range? What can come out of there?
Would it be negative infinity to infinity?
That's exactly the range. Who was that?
Benny.
All right, Benny, that's good. Thank you for answering.
No problem.
Okay. All right, we have a more difficult problem here. X plus 2 over 2x minus 3. Okay, who wants to talk me through this one?
I'll do it.
Okay. So how do we start?
We substitute f of x for y.
Good.
And
All right.
then we'll multiply both sides by 2x minus 3.
Oh, we got to do one thing first.
Switch X and Y.
Oh, yes, switch x and y.
All right. Thank you. Thank you. I like that. Y'all are helping each other. So switch X and Y. Okay, Ian, what do we do next?
So then we will multiply both sides by the 2y minus 3.
Good. Okay.
Then we would divide by the, actually not, we could subtract the 2 on both sides.
What are we going to do?
Subtract the 2 on both sides.
Okay, we can do that. Still have some work to do.
Then we can divide both sides by y.
What am I trying to solve for?
Oh, no, actually not for fine, I'm pretty sure.
We're trying to solve for what?
Oh, we have the 2y over there, yeah.
Yeah, we got to get that out of there. How do we get that out of there?
So first things first, we have to separate that x.
We don't want to separate it. We want to distribute it.
Okay, yeah.
Okay.
So then it would be 2y times x and then the x times the negative 3.
Okay. So now what do I want to do?
Then we can divide by the
Can't divide yet. I'm still trying to get this y and this y need to be on the same side.
Subtract the 2xy and then divide by
So
2x.
I can take this 2x and move it over here.
Yeah. I was saying to move that whole thing over.
So
Yeah, subtract that
I
over
have
there.
minus 3x minus 2 is equal to y minus 2xy.
And then we can divide the 2x and then get it back to the other side.
I still need to do one more thing. I need y all by itself. Okay?
Okay.
Ian. Now,
Yeah.
now,
Now We can divide the y finally.
Yes. So now we're going to get y. Okay. And I can even simplify that one more. Okay, are we happy with that?
Man,
I'm happy with that. Ian, you should be happy with that. Skylar, thank
definitely.
you. Okay, so now we have an inverse. What's the domain? Let's write it in interval form. What's the only thing that can't go in there?
Positive 1/2.
1/2. Good. So x cannot be 1/2. So I can put minus infinity up to 1/2. I can union that with 1/2 infinity. I can write that set of all x such that x is not equal to 1/2. Okay, now here's the hard part for this problem. When you have a problem like this, the range is difficult because it's very hard to see all the numbers x that are going to come out of this. But I give you a hint. The domain of f is the range of f inverse. Well, the domain of f inverse is the range of f. And the range of f inverse is the domain of f. So I'm trying to find, I already know that the domain, so let's just check. Look at the domain of f, okay? X can't be 1/2. So if we go back to the original problem, where is it? I don't know where it is. There we go. So that's what the domain is. That was easy to find. What's the range? So what's the domain of f? Let's go back and look at this function. For the domain of this function right here, x cannot be what? For f, this was f. X cannot be what?
1.5.
Okay, good. So from f, so we go back to f. In our domain of f, x cannot be 3/2. So that has to be the range of f inverse. Okay. Let me make sure I put inverses on these because that's what we were trying to find. Okay. So we looked at this function and we could easily see just by looking at it, x could not be 1/2. So that easily told us what the domain was. But it wasn't easy to see the range. But I do know that if I look at the domain of the function, that will be the range of the inverse. So I went back, and when I went back to the function, I saw that I couldn't put 3/2 in there. So therefore, that is what becomes the range of the inverse. Okay, any questions? So
I have a
normally,
question.
you have a question? Yes, Lauren?
So for the, I know that we wrote the domain in interval form. Do we also write the range in interval form?
Yes, you can. Good question. How would you write it? Lauren?
I put -infinity to 3/2 union with 3/2, or in parentheses, not brackets, union with parentheses 3/2 to +infinity parentheses.
That's correct.